Hello and welcome. In this video, we're going to learn how to calculate equivalent resistance of any circuit. Alright, so this problem before us, how do we approach it? What is the best way to approach it? Right, the best way to approach this problem is to simplify the circuit as much as you can. And in the process of simplification, we're either going to have series circuit or parallel circuit. And step by step, we're going to solve the problem. Right, so now taking a look at this circuit, how can we best simplify? Right, how can I make this circuit easier for me to, find the equivalent resistance? Okay, so here I have 150 ohm resistor, and here I have a 70 ohm resistor. It is very obvious that 150 ohm and 70 ohm are in series. How do I know they are in series? Whenever current moves in a single direction without changing, let's say current I moves through 150. This same current I will move through 150 and this same current I will move through 70. Okay, there is no change in current. When current flows through a resistor and flows through another resistor without changing direction, that means these two resistors are in series. So this simply means that for series circuit, the same current flows through them. Alright, so how do I find the equivalent resistance for series circuit? R equivalent for these two resistors, R equivalent will be 150 plus 70. Alright, so 150 plus 70 is what? 220 ohms. So I'm now going to redraw this circuit and I'm going to have one resistor, which is the equivalent resistance. So let me redraw the circuit. Alright, so I have an equivalent resistance of 220 ohms. Now I'm going to take a look at this circuit one more time. What can I easily simplify? I can easily simplify these two circuits, these two resistors, 90 ohms and 220 ohms. 90 ohms and 220 ohms are in parallel. How do I know they are in parallel? As current enters this junction, current will move towards the 90 ohms and another current will move towards the 220 ohms resistor, which means that current changes direction unlike resistors in series. So because this and this are in parallel, to calculate the equivalent resistance, I have two approaches, two methods. I can say that 1 over R equivalent is equal to 1 over 90 plus 1 over 220. Now I can also say that R equivalent for these two resistors is equal to 90 multiplied by 220 divided by 90 plus 220. Both approaches would give me my answer. But when I have three resistors in parallel, this method is not allowed. Alright? Because this simplifies to this. Alright, so when we solve this, 90 times 220 divided by 90 plus 220, we're going to get our equivalent resistance to be equal to 63.870. So let's redraw our circuit with one resistor of 63.87 ohms. Okay, taking a look at the circuit again, I can see that current moves through 130 ohms and that same current moves through 63.87 ohms. What does that tell us? That tells us that 130 ohms and 63.87 ohms are in series. Alright, so the equivalent resistance for that will be 130 plus 63.87. And what will that give us? That would give us 193.87 ohms. So I'm going to redraw my circuit to have one resistor with an equivalent resistance of 193.87 ohms. Alright, so taking a look at the circuit again, I can see that 100 ohms and 193.87 ohms are in parallel. How do I know they are in parallel? When current enters this junction, current will flow towards the 100 ohms and another current will flow towards the 193.87 ohms, right? Which means that these two resistors are in parallel. I can also decide to redraw my circuit to make it look much more understandable. So let me call this place junction A and let me call this junction B. Okay, in between A and B, I have 193.87 ohms. So let me draw this. I have A, B, 193.87. Also in between A and B, I have an 100 ohm resistor. So I can draw it this way, that I have an 100 ohm resistor in between A and B. Alright, so it is very, very obvious that 193.87 and 100 ohms are in parallel. So how do I solve for the equivalent resistance? R equivalent will be 100 multiplied by 193.87 divided by 100 plus 193.87. If I have three resistors in parallel, This is just an assumption. Let's assume that this is 20 ohms. Right, to solve the equivalent resistance of these three resistors, we're going to go with this approach that 1 over R equivalent equals 1 over R1, 193.87, plus 1 over R2, 100, plus 1 over R3, which is 20. So this is how we do that when we have three resistors. But when we have two, this is a very much faster way to solve it. Alright, so that's just by the way. So back to the problem. R equivalent, when we solve this, R equivalent will be 65.97 ohms. Alright, so we're going to redraw our circuit to have an equivalent resistance of 65.97 ohms. Alright, so once more we're going to take a look at the circuit, and we can see that these two resistors are in parallel. Alright, and I've explained this, that current changes direction, and because current changes direction, an amount of current goes into 30 ohms, another amount of current goes into 65.97 ohms resistor. So these two are in parallel. Alright, so we solve this parallel circuit, and our R equivalent for 30 ohms and 65.97 ohms resistor will be 30 multiplied by 65.97 divided by 30 plus 65.97. And what are we going to have? We're going to have 20.62 ohms. So the next thing for us to do is to redraw the circuit. We're going to have an equivalent resistance of 20.62 ohms, replacing 30 ohms and 65.97 ohms. Alright, so after all the simplifications, we are down to 3 resistors. Alright, and we're looking for equivalent resistance. So taking a look at this, current flows through 60 ohms. The same current flows through 20.62 ohms. That same current flows through 40 ohms. And so we can conclude that 60 ohms, 20.62 ohms, and 40 ohms are in series. Alright, so because they are in series, the equivalent resistance, which will be the equivalent resistance for the circuit, for the entire circuit, will be equal to 60 plus 20.62 plus 40. And finally, we're going to get our answer as 120.62 ohms. And this is the answer to the question. Alright, so when we redraw our circuit, it will look like this. An equivalent resistance of 120.62 ohms. And a battery source of 15 volts, and we have a current source flowing through this resistor, and this is the answer to the question. And we've come to the end of this video. Thank you very much for watching. Don't forget to like, share, subscribe, and drop your questions in the comment section. Goodbye.